Hello, dear colleagues, and this is the second presentation. And at this presentation, I would like to give you some introduction on the chemical space where we are widely using in cheminformatics research. And my name is Professor Sergey Shityakov. I'm a head of cheminformatics group at the Scientific Center of Infochemistry in the ITMO University. And what is the chemical space? The chemical space is a vast space which represents various molecules and chemical fragments that can also represent bigger molecules like even proteins and some smaller biological substances like peptides. But usually the chemical space in cheminformatics encompasses various drug-like molecules. They are not big molecules, they're usually small organic molecules. And by implementing different cheminformatics algorithms, we can try to structure this space, cluster different substances into different groups to understand their biological activities, and possibly we'll try to identify those substances which we are calling hits to develop them into a very potent medication to treat different diseases. As you can see here, the chemical space is a vast space which probably has the number of the molecules starting from 10 to 9 to 10 to 14 power. And usually the task we are calling to find, it's like to find the needle in a haystack. How we can actually analyze the chemical space? We can analyze the chemical space using objects plus metrics, where the objects are the molecules and the metrics are the properties of these molecules. On this slide, I would try to give a couple of examples and how we are going to structure this chemical space. Either we are using the graph-based techniques, or we are trying to divide the properties of the molecules into descriptor-like values. And the descriptor-like values might be the steric descriptors, hydrophobic descriptors, electronic descriptors, and usually the descriptors are the properties where we think might be useful to select various candidates as for the novel hit molecules. The descriptors might be the affinities between protein and the ligand, or the descriptors might be also the physical chemical properties, for instance, the solubility of the molecules, the lipophilicity of the molecules, and all the descriptors which are necessary to analyze in order to structure the chemical space. And the chemical space might be also analyzed in accordance to the cheminformatics paradigm. And on this slide, I want you to have a look at this paradigm where on one hand we have the chemical database, which represents the chemical space. On the other, we have different techniques where we can implement to analyze this chemical space. And these techniques including different filters as a filtering algorithm similarity, searching algorithms, quantitative structure activity relationship models, pharmacophore models, and different techniques which are based on the molecular docking. These techniques are widely used for the virtual screening because they are quite fast in terms of the speed, but of course at some point they're lacking the accuracy. Therefore, we have to validate these techniques using more sophisticated methods like molecular dynamics or quantitative or even some hybrid methods where we combine in the molecular dynamics and quantum mechanics techniques. But of course, these methods are more laborious and very time consuming. And virtual screening sometimes is called the high throughput screening, but the difference between the virtual screening and the high throughput screening in processing of different molecules. If we are using the big number of the molecules, then we are talking about the high throughput screening. If we are using the small number of the molecules, usually we are talking about the virtual screening. And finally, we would come up after the high throughput screening or the virtual screening, we would come up in a small number of molecules, usually from 10 to 100 or 1,000 of molecules, which are ready to be analyzed using more laborious techniques. And the rest of the molecules can be considered as inactive, so we are going to discard these molecules from the further analysis. Therefore, this cheminformatics paradigm can be subdivided into the two groups. One group is the ligand-based methods, and the other group is the protein-based methods. The first group usually includes very fast algorithms such as filtering algorithm, similarity searching algorithm, pharmacophore searching algorithm, and etc. And the protein-based group usually includes techniques which are based on the molecular docking, where we are trying to investigate the interaction between protein and the ligand. What are the types of the lattice agent of the models we are trying to investigate in cheminformatics, and what is the reason of these models and how we can actually implement them in our research. As you can see here, we have some kind of a pyramid, either using a deductive learning or inductive learning. So we can go from the data to knowledge and vice versa, from the knowledge to data. So the idea is that cheminformatics learns from the experimental data. I also put some of our results where you can see that we clustered our molecular docking data, where we have some molecules which are interacting with some proteins such as blood-brain barrier transporter, and using the cheminformatics techniques, the molecules are nicely clustered into two groups. One group is active, and the other group is inactive group of the molecules in terms of this interaction. So what are the basic concepts of cheminformatics? I would name just a few, such as quantum chemistry, analyzing the wave-particle dualism, force field molecular modeling based on classical mechanics, and the cheminformatics, which is based on the chemical space. Usually these categories, they intermingle, so analyzing the chemical space, one could try to implement some more sophisticated techniques, but one should also keep in mind that the processing time might be extremely low for the vast majority of the molecules which are included in the chemical space. These subdivisions are usually artificial, but to simplify the subject, we could say that cheminformatics is the discipline which is mostly involved in analysis of the chemical space. And I would say a couple of words about the the basic concepts in terms of the analysis of the molecular entities. And if we will take different disciplines, we might say that in terms of quantum chemistry, we are analyzing electrons and nuclei. For the force field molecular modeling, we are using atoms and bonds. And in cheminformatics, we are using the molecular graphs and different descriptor vectors. Therefore, cheminformatics is a field which is based on the representation of the molecules as objects, graphs, and vectors in the chemical space. And this would be all for the chemical space, and I thank you for your attention.